All right. Yesterday, we looked at the trapezoidal rule and we showed how to turn the trapezoid area formulas and turn it into a kind of general formula for that area of a trapezoid. So today on these problems, I'm actually going to jump right to that area of a trapezoid formula, or that trapezoidal rule formula when we do these. But I will draw the picture just to give us a visual of what this looks like and what each trapezoid might look like to give us a sense. So I'll draw two of them. Trapezoidal rule with n equals 6. So that means we're drawing 6 of these trapezoids. From 0 to 1, 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6. So we're going to start with the one from 0 to 1. Take your height of the first. Take your height of the second. And then we're just going to connect the dots. And that creates our trapezoid. And then we'll do this same thing for the second one. There's your height at 1. And here's your height at 2. And then we're just going to connect those points. Height at 2, height at 3. There it is. Connect those points. Height at 3, height at 4. Connect those points. And remember, the point of this is that our estimate for these is much better than what we would get with rectangles. Much closer because we are just connecting those endpoints. But the disadvantage is that the formula is a little bit more complicated. So when we're talking about the area being h over 2 times base 1 plus base 2, remember that our height connects my two bases, and my two bases are actually the y distances. And so the height is my x distances. So h is 1, which is going to make our h over 2 that we're going to take out of the whole thing 1/2. And I can take it out of the whole thing because all the intervals are evenly spaced. So I'm going to take a 1/2 out of the whole thing. And again, we're going to jump straight to our formula here. Remember that in the formula, all of them are going to have a 2, are going to be doubled, except for the leftmost point and the rightmost point. Because all the other ones have repeated bases. The right base of the first one becomes the left base of the second one, and so on, except for the endpoints. So only 1 12, but then we have 2 10s plus 2 times 9 plus 2 times 11. And remember, this formula can only get used if the intervals are evenly spaced. So on the homework, when you come across ones when they aren't evenly spaced, you're going to have to think of it just as a trapezoid formula. 2 times 16 plus only 1 18. So the only ones that don't have the 2 out in front are the first endpoint and the last endpoint. So that is what the sum looks like. And if I add these all up, I get 148. So if I cut that in half, I should get 74. So that is my area with the trapezoidal rule. Last time we said, here's what the actual answer was. This time we don't know because we don't know what the original function was. but we know that this should be closer than if I just use rectangles. Last one here in the notes, we are looking at doing a volume of a swimming pool. So if we think about a rectangular swimming pool, that means that if I'm measuring out this swimming pool, I can only work in 2 dimensions here. Here's my rectangle, and we are 30 feet wide and 50 feet long. This is showing where the integral formula is coming from, because they might ask you to actually work out what the integral formula is. And so what we are doing is saying that we are picking lengths along the pool and saying at these different lengths, the depth of the water is different. And so we need to factor that in. So at 0, it's at 6. At 5, it's at 8.2. So it's getting deeper as I go along the swimming pool. That's the idea. And so the way that we're going to do this is that if I wanted to turn this into a general formula, it would be the length times the width times the depth. And at each of these, the width stays the same, but at different lengths, the depth changes. And so we're going to accumulate each of those depths at each of these different lengths. That's where the integral comes in. We're going from a length along the pool of 0 all the way up to 50 and saying at all of them, we're going to take length times width times depth. The width doesn't change. So really, I can say that we're taking a 30 out of this whole thing. From 0 to 50 of h of x dx. So a 30 is going to come out of this whole thing. And then in this space, you're going to put the trapezoid formula. Sub 10. And so I'm going to give you a couple minutes to actually write out what the formula is going to be for the trapezoidal rule. So I'm going to give you a couple minutes to try this on your own before I show the answer here. Here comes your setup. All of them have 2's except for the first endpoint and the last endpoint. Our height was 5. That's our x distance. And remember that height gets over 2 because that's part of the area formula. And we should get 15,990. At least that's what I got from my calculator. I may have calculated wrong. I know for sure this setup is right. And that should be, since it's a volume, that should be feet cubed. And so if you're thinking about it, the y distance is feet. The integral is going to make it feet squared because integral is measured in area. And then we're going times our width. So we're multiplying by feet by 30 feet again. So we have a feet squared times feet being feet cubed. And so that is our setup. All of them have 2's except the first and the last. Remember, on the homework, some of them won't have those evenly spaced intervals. And so keep an eye out for those. If they're not evenly spaced, we can't use this easier form of the formula. We have to think about the trapezoid area formula for each individual piece, like we did on the first example.